Do you know I can fly like a Superman unless you observe me? Unless I think about my postponed board exam, I already gave my board exam and I secure 4 GPA. You will never be late unless someone check clock. Let's take one famous experiment known as Schrodinger experiment, where one cat is kept on a box by supplying sufficient radiant so cat will die, but until you open box, cat will be in state of both dead and alive. There are some simple examples which show how complex and quantum physics is. According to theory of superposition, electron or particle will be in every possible state, but when you observe it, all wave function will collapse and you will see only one. Quantum physics mostly talk about the possibilities. While talking about quantum physics, how can I neglect Schrodinger equation? Schrodinger equation has two types. One, time dependent, second, time independent. The famous equation of Schrodinger time independent is represented as E psi coordinate x is equal to minus h cut square upon 2m second derivative of psi with respect to s b psi coordinate x. Here psi coordinate x indicate for one dimension. For more dimension we can take psi x coordinate, y coordinate and z coordinate also, where psi is symbol of wave function. In simpler form we can express Schrodinger equation as I h cut first derivative of wave function with respect to time is equal to minus h cut square upon 2 mu second derivative of wave function with respect to x plus v into wave function, where I represent imaginary number h cut is equal to h upon 2 pi, where Planck constant is equal to 6.62 into 10 to the power minus 34. Mu is represented as mass and v into wave function is equal to potential energy, where minus h cut square into second derivative of wave function with respect to x represent kinetic energy. We can calculate probability distribution by multiplying conjugate of wave function with wave function. When we multiply conjugate of wave function with wave function, imaginary term will remove. Let's take one simple example showing how imaginary term will remove. When we will multiply it with its conjugate, assume z as wave function which value is a plus ib. Then its conjugate value become a minus ib. When we multiply conjugate of z with z, we get value a square plus b square. Here we can clearly see I is removed. If we take electron which is orbiting in fixed place, but wave function shows some result outside of possible place, or let's assume you are locked on room, and if wave function show result of you also being outside, well, forget about tunneling effect. Then shouldn't we normalize it? Of course we should normalize it. Or when integration of conjugate of psi into psi dx is greater than 1, then we need to normalize it by multiplying with normalization constant a. So new wave function become a psi. Saying about it, you may also have a question. If psi is our main wave function, then putting a, will it affect our main equation? Let's see. Our main equation is I h cut derivative of wave function with respect to time is equal to minus h cut square upon 2 mu second derivative of wave function with respect to x plus v into wave function. Our new wave function psi 1 is equal to psi a. So putting this value we get I h cut derivative of psi a with respect to time is equal to minus h cut square upon 2 mu second derivative of psi a with respect to x plus b psi a. Since a is normalization constant, derivative of a will be a. Taking out common from a from right side and left side, and after cancelling a from each side, we got same equation as first or as our main equation. So a will not affect value, it just remove imaginary part and help to find right probability distribution. Thank you.